Supervised learning. Unlike supervised learning, unsupervised learning algorithms train on unlabeled data. The training model learns from data without any guidance or known outputs and labels. It scans through the input data, trying to group them together according to their similarities, such as colors, sizes, shapes and others. There is no right and wrong answers. The objective is to analyze the data, to find hidden patterns and groupings within the data. As the training data, for unsupervised learning, does not require labeling, setup is easy. It saves a data scientist from having to label everything, which can be a challenging task. No data labeling also means no preconceived ideas and no bias. However, the limitation of this method is that it cannot give precise predictions. Here are some problem types, or use cases, that can be addressed by unsupervised learning. Dimension reduction. Dimension reduction is used to determine the most relevant features to use for model construction. It is the process of reducing the dimension of your feature set, such that it still retains the most significant properties of the original data. This helps in data compression and feature selection. Cluster analysis. Cluster analysis is used to classify objects into groups, called clusters. It attempts to find discrete groupings within data, where members of a group are as similar as possible to one another, and as different as possible from members of other groups. Cluster analysis is used in applications such as market research and image processing. Anomaly detection. Anomaly detection is the identification of outliers or observations in a data set which raise suspicions because they differ significantly from the rest of the data. The identification of anomalous items can be used, for example, to detect bank fraud or medical errors.